Now, in our last video, we learned how to deal with non-perfect squares where mathematicians could work with them by estimating or rounding the answer. Today, we want to learn about another thing that mathematicians do when they work with non-perfect squares, because if they don't want to be close but not exactly there, but if they want to be exactly where they're supposed to be. In other words, if I had something like the square root of 48, okay, and I'm a mathematician, I get this result and I need to work with it. And I don't want to estimate it, I want to be exactly the square root of 48. Then I could leave it the square root of 48, or what I could do, and what mathematicians do a lot of times, is they write it in simplest radical form. And again, just like we have fractions that we simplify to make easier to work with, we have radicals that we can simplify and make easy to work with. Now, in order to do this, the first thing you need to understand is that the square root of a times b is equal to the square root of a times the square root of b. Now again, what that means is if you could take a number and break it up into parts, then you could take the square root of part of it. For example, a good example of this would be the square root of 100, okay? Because can't you break 100 up into 4 times 25? And then you could break up the square root of 4 times the square root of 25. Now, the square root of 4 is 2, and the square root of 25 is 5. And what's 2 times 5? 10. So the square root of 100 is 10. Now again, you say, well, we already knew the square root of 100 was 10. Yeah, but you could do this with any number, okay, if you could break it up into a product of perfect squares. Now, you look at 48, the square root of 48, and you can't break it up into a product of squares because it's not a perfect square. But you could try to find a perfect square that goes into 48. Does anyone know a perfect square that goes into 48? Think about it for a minute. Think about your times table in 48. Most probably you might come up with, I would kind of hope, the square root of 4 times 12. Because isn't 4 times 12 48? So now I could break this down into the square root of 4 times the square root of 12. Now the square root of 4 is 2, and the square root of 12 is a non-perfect square. However, you could break 12 down because there's a perfect square that goes into 12. Anyone know a perfect square into 12? You guessed it, 4. So you could break this into 12 times 4 times 3, which is 2 times the square root of 4 times the square root of 3. And again, now, the square root of 4 is 2, and the square root of 3 cannot be broken down anymore. It's a prime number. So 2 times 2 is 4, and your answer comes out to be 4 times the square root of 3. And this would be in simplest radical form, because I took out all perfect squares that were factors of 48 and took the square root of them and left in what wasn't, okay? So again, that's how you write something in simplest radical form. You look at the number and you try to find a perfect square that goes into it evenly. By the way, in most textbooks and in high school when they teach this, they just expect you to know your times tables really well so you could figure it out. By the way, I think a lot of teachers in high school might even expect that you know that 48 is equal to the square root of 16 times 3. Because 16 times 3 is 48. And then you could go with the square root of 16 times the square root of 3. And the square root of 16 is 4 times the square root of 3. Now that's great if you're a person who can see that. And by the way, there's a couple of you who might have known 16 goes into 48. I don't know. But I know one year I was tutoring a boy at Brother Martin. This was about 20 years ago. And he had trouble even knowing that 4 times 12 was 48, and that 4 was a perfect square. So I was having trouble with him trying to get him to pick out the perfect squares that are factors of a number. And then I came up with an idea. I said, I know what, let's do the factor tree of 48. And again, I think everybody in here would know that the factor tree for 48, you could break it up into 8 times 6, and you could break that up into 2 times 4 and 2 times 3, and you can break that up into 2 times 2 times 2 times 3. I'm sorry, I skipped the 2 times 3. Now again, once you got the factor tree, you want the square root of that. However, isn't a perfect square a number times itself? So every time you have a number times itself, you could actually take it out from under the radical, because you see 2 times 2 is 4, and 2 times 2 is 4. So you actually have the square root of 4 times the square root of 4 times the square root of 3. And again, square root of 4 is 2 times the square root of 4 is 2 times 3 is just 4 times the square root of 3. Now this is what's really happening, okay? But you can actually skip this whole part here by just saying to yourself, 2 times 2 is 4, and the square root of 4 is 2. So you can take out a 2. Every time you have a pair, you can take it out from under the radical. Once, not twice, once. And leave what's not in pairs here. So 2 times 2 is 4, and your answer is 4 square root of 3. Now, again, if you can look at a number and see a perfect square that goes into it, you can just break it up with the perfect square that you can see. But if you don't know the perfect square that goes into it, this is a good way to do it. Let's look at a couple of other examples just to make sure you understand what we're talking about. If I want the square root of 72, all right, I could break 72 up into 9 times 8, and 9 up into 3 times 3, and 8 into 4 times 2, and that would be 3 times 3 times 2 times 2 times 2. So if I wanted to find the square root of this, again, for every pair, you take out one factor. So 3 times 3 is 9, the square root of 9 is 3, I can take it out from under the radical. 2 times 2 is 4, the square root of 4 is 2, I could take it out from under the radical. And that leaves me with just 1 2 under the radical. Now 2 times 3 is 6, square root of 2. And again, that's in simplest radical form. Now again, if you looked at 72, and you happen to know that 72 is equal to the square root of 2 times 36, well, what's the square root of 36? 6. 6 square root of 2. So if you see the perfect square that goes into it, you can use it. And again, you could check through your perfect squares and see if any of them go. And you go, what perfect squares? Remember the 15 perfect squares that I gave you in the beginning? You could notice, you could run through those and see if any of those go. But again, I have found that most of the students I teach, since you've done factor trees for a long time and you're pretty good at them, okay, I think a lot of people like to do it with the factor tree. But be careful. When you do it with the factor tree, make sure you take out one for every pair and leave under what isn't in pairs. Some people mix it up and then they get it totally wrong. And when I say mix it up, what I mean is when they're not in pairs, they take it out from a radical, and when they're in pairs, they leave it in. So don't do that. That's not how you would do it. So let's look at one more just to make sure that you, excuse me, have how to do this. Let's see. Let's do the square root of 120. Now again, to do the square root of 120 with factor trees, you break 120 down into 10 times 12. And then you can break 10 down into 2 times 5, and you can break 12 down into 4 times 3, And you can break that down into 2 times 5 times 2 times 2 times 3. And again, this whole thing would be under the square root. Now for every pair, you can take one out. So I have a pair of 2's, 2 times 2 is 4, the square root of 4 is 2, I take a 2 out. There are no other pairs. So that means underneath the radical, you have 2 times 5 is 10 times 3 is 30. So your answer would be 2 square root of 30. And again, if you use the factor trees, for every pair that you have under the radical, you take one out. And for everything that's not under the radical, you multiply times each other to get your answer. So this is the other way that mathematicians work with non-perfect squares. They can either estimate and round them, or they can write them in simplest radical form. And again, it depends on what you want. If you want to be exact, then you want it in simplest radical form. If you want to be just basically around what it is, then you round. If you're happy enough with it being closest to the nearest tenth or hundredth, then you round. If not, you write it in simplest radical form. And I promise you, when you go into Algebra 1, you're going to have to know how to write numbers in simplest radical form. By the way, I was surprised. I thought I made up this way with the factor trees, but I noticed that last year when I was helping Michael Buisson and Ethan with tutoring him at Jesuit, that the teacher at Jesuit told him to do the same thing. So what do you know? Some things are not original. Other people figure them out. But you can do it by looking for the square root that goes into it, or you can do it by doing the factor tree and taking out the pairs. All right, so this is what your last part of the skills test will be on when it deals with finding simplest radical form.